What does it mean to remember something? What is an emotion? What happens in our mind when we're thinking? Each of us is intimately familiar with the things we remember, with the emotions that we experience. But these phenomena are complicated experiences. In this lecture, I'll provide an overview of the nature of human memory, cognition, and emotion. As you listen to this, I invite you to enter this with an open mind. Although each of us remember events, store memories, recall them and bring them to mind, solve problems, feel emotions, when asked to define what a feeling is, we might struggle to come up with a great definition, because so many of these things are felt experiences that only we can intimately know. So in this lecture, what I'll present is sort of the information as we know it about how memory, cognition, and emotion work. I hope you find this interesting and enjoyable. It might be helpful to take notes as you follow along, and I will be posting these slides up on Canvas, so you'll also be able to access these slides in PowerPoint format. And this lecture serves as the introduction to Unit 3, as we'll be exploring the human mind and talking about how memory, cognition, emotion, and consciousness work and how they develop across the lifespan. Here's an outline for this lecture and some guiding questions. I'll start off by discussing memory, move into a discussion of cognition, and finally provide an overview of the nature of human emotions. It might be helpful to pause this video and write down these guiding questions. By the end of this lecture, you should be able to answer these questions. So the first topic that we'll talk about is memory. And as we begin this discussion of memory, I invite you to call to mind some of your most pleasant memories. In this lecture, I'll be talking about how those memories were formed, and perhaps more interestingly and surprisingly, what happens when you recall them and bring them to mind. So first, let's start out with a definition of memory. Memory is an active cognitive system that receives information from the senses, converts that information into usable form, organizes and stores that information, and retrieves that information from storage. And there's two major components of the memory system that we'll be talking about. One is memory storage systems, and we'll be talking about two main memory storage systems. And the second are cognitive processes that influence the functioning of the memory system. There are two main memory storage systems that we'll cover in this unit. The first being short-term memory, the second being long-term memory. You can think of these as two separate systems that operate alongside one another. First, we'll talk about short-term memory. Short-term memory refers to a storage system in which information is held for brief periods of time while being used, specifically about 15 to 30 seconds. The process by which information gets to short-term memory involves two major steps. The first is a process called encoding. Encoding refers to mental operations people perform on sensory information to convert that information into a form usable in the brain's storage system. For example, as you listen to this online lecture, your mind is performing mental operations on the auditory stimuli that you are listening to and converting that information into a form usable by the brain's memory storage system. However, an additional process is filtering that information that is encoded. And we refer to that process as selective attention. This is a mental process that determines what sensory information enters short-term memory. Often, information is filtered based on its importance. So right now, your mind might be filtering out unimportant sensory stimuli, such as the sound of a heating or air conditioning system, conversations in the background, music or sounds of traffic that might be in the background, and, because this lecture is so important, selectively attending to the information that you're listening to. So information that is encoded, that passes through this filter, is stored in short-term memory, and this is a memory storage system that holds information for brief periods of time, often for information that's being used in the moment. Sometimes information can be held in short-term memory for longer periods of time if it's actively worked with through a process that we call maintenance rehearsal. This refers to a process by which an individual actively works with information that's stored in short-term memory to keep it in short-term memory for longer than 15 to 30 seconds. For example, you might ask someone for a phone number, they might tell you the number, and you might repeat it over and over in your mind for maybe a minute before you have a chance to put it in your phone. So again, this is one memory storage system, short-term memory. This is a system in which information is held for brief periods of time while being used. A separate memory storage system is long-term memory. This is a memory system in which information is stored permanently. Like with short-term memory, the first process relevant to long-term memory is encoding. Again, the mental operations people perform on sensory information to convert it into a form that's usable in the brain's memory storage system. However, not all sensory information that's encoded enters into long-term memory. Indeed, you've probably had the experience of sitting in a class, listening to information, maybe even paying attention to information, maybe even taking notes about a topic, maybe even studying something, and having that information not stick. Information enters long-term memory through a process called rehearsal. And there's two main types of rehearsal that we'll discuss: elaborative and maintenance. One of these, elaborative rehearsal, is far more effective for getting encoded information stored in long-term memory. Elaborative rehearsal is a way of transferring information into long-term memory by making that information meaningful in some way, by connecting it with other information already stored in long-term memory, by connecting that information to imagery or to emotion, or by assigning some sort of meaning to that information. This is one reason why in class I have you complete applications. As an example for understanding what elaborative rehearsal is, during Unit 1, you learned the ethical principles of research within psychology. But also in class and for homework, you had to apply those principles to a specific example. The goal there was to connect that information with some sort of meaning. In other words, having you engage in elaborative rehearsal so that information is stored in long-term memory. The other form of rehearsal that is less effective, but still sometimes effective for storing information in long-term memory, is maintenance rehearsal. Maintenance rehearsal simply involves repetition of information that is encoded several times over. For example, you might repeat something over and over. You might use flashcards to attempt to store the definition of a term in long-term memory, and so on. Again, research suggests that elaborative rehearsal is more effective than maintenance rehearsal. And this is a reason some study strategies might work better than others for storing information in long-term memory. Retrieval describes the process by which information is gotten out of long-term memory and converted into a form that can be used in the present moment. So when you call a long-term memory to mind, if it's an event, for example, or you recall or retrieve a fact or piece of information from long-term memory, we call that process retrieval. Reconsolidation refers to a process by which information is then restored back into long-term memory after you've retrieved it and called it to mind. So oftentimes we like to think of our memory as working much like the storage systems on a computer or a video of some kind, where we record the images of an event, much like we might record a video, and then when we call that memory to mind, it's much like playing a video that we watch, and then that memory stays stored as is. Or we remember a piece of information, store it much like saving a file on a computer, call it to mind like we might open a file on a computer, and then close that and save it back into our memory. But in fact, our memory does not work like that at all. When we call memories to mind, we often work with those memories in some way. The information we bring to mind when we retrieve a memory from long-term memory is often revised and altered to incorporate new information. Our mind fills in the gaps based on available information at the time, or things maybe we've learned or experienced since we've stored that long-term memory. At the beginning of the unit, when in class we watched a video of a mock crime being committed, and you had to identify the suspect from that crime from a lineup. The accuracy rate for our class was very low. We talked about the reason for that. And it's this constructive processing. When we store episodic long-term memories, which are memories of events that have happened, we often store fragments. And when we call those memories to mind, our mind fills in missing information, often using information that's available after the fact or in the present moment when the memory is called to mind. And a similar thing happens when we call to mind and retrieve facts from memory as well. And then when this information is reconsolidated or restored into long-term memory, it may often be stored in a manner that's different from how it was first stored. For example, when you watch the video of the pretend crime happening in class, stored that memory in long-term memory, the image of who was committing that alleged crime may have been somewhat fuzzy. But then when you saw the police lineup and called to mind from long-term memory the memory of that alleged crime being committed, your mind might have used the available information of the people you saw in the lineup. And even though the actual person who committed the crime was not there in the lineup, your mind may have filled in the gaps based on the available information of who was there in the lineup, and then restored that memory in its altered manner. We call this constructive processing. Memory is constructive. Each time we call memories to mind from long-term memory, our mind reconstructs them. Most of the time, this is accurate. But sometimes, like with any cognitive process, this is susceptible to error. So let's talk a little bit more about long-term memory and the different types of permanent storage within the long-term memory system. The first long-term memory system that we'll discuss is procedural long-term memory. And this is the memory storage system where things like motor skills and reflexes are stored. So for example, information about how to ride a bike, how to dribble a basketball, how to throw a softball are stored within procedural long-term memory. A separate subsection within long-term memory is declarative long-term memory, and there's two types of declarative long-term memory. The first is episodic long-term memory, and these are memories of events experienced by a person. Examples of episodic long-term memories might be your first day of college, and so on. And then semantic long-term memory includes information stored in long-term memory, such as facts and general knowledge, information such as George Washington was the first president of the United States, and so on. So to summarize, memory is an active system that receives information from the senses, converts the information into usable form, organizes and stores information, and retrieves information from storage. It's a constructive, active process. The next topic of this online lecture is cognition. In other words, thinking. Cognition is the mental activity of processing, organizing, understanding, and communicating information. There are two main components to cognition. The first involves language processes. We refer to this component of cognition as verbal activity. People often think or engage in cognition using language. Language is not just speaking and understanding what others say or using signs, but language more broadly is defined as a system for using arbitrary symbols, letters, words, signs, to facilitate mental activity and to communicate with others. Much of our cognition, or our thinking, occurs using language processes. In fact, our thinking and language are intimately intertwined and impossible to separate from one another. They co-develop over time, and in essence, they are almost one in the same. So again, language describes a system for using arbitrary symbols like letters put together to form words that then represent objects or situations or ideas or concepts. And we then use those symbols and our system for combining them to facilitate mental activity and communicate with others. We also think using mental imagery, mental representations of objects, people, and events that have almost a picture-like quality. People often mentally interact with these images. For example, you could call to mind an image of our classroom and picture where things are, where you normally sit, etc. But you can also engage in verbal activity about our classroom, using the word classroom and symbols to represent various objects within the classroom. Cognition is an evolutionary adaptation. Language and mental imagery are evolutionary adaptations, evolved through natural selection. The ability to combine arbitrary symbols, to think, the ability to picture images in one's mind, helped our species to survive and thrive. And those abilities were passed down through generations and advanced and evolved through natural selection because they helped us survive as a species. What a great ability to be able to plan for the future, to be able to imagine situations that have not yet happened. And we use cognition for a variety of important purposes: to solve problems, to categorize stimuli and objects that we encounter, to organize information that we've learned, and to reason and draw conclusions. But sometimes, because we're human, we can make errors in cognition. Cognitive errors describe the result of cognitive processes that lead to incorrect conclusions. Probably the most common cognitive error involves something called the confirmation bias. You've probably heard of this before. And this is the tendency for human beings to search for and believe evidence that fits with one's beliefs while ignoring and disbelieving evidence that does not fit with those beliefs. For example, if someone developed the belief that human beings play no role in climate change, someone might only notice and buy into evidence supporting that belief and ignore or miss or come up with many reasons, this oftentimes happens outside of awareness, to disbelieve evidence that does not fit with that belief, even if that evidence might be overwhelming in nature, if one were to look at a situation purely objectively. So in this way, prior beliefs influence how we seek out and interpret and judge and evaluate information. So prior cognition influences later cognition. And that's a reason that human beings are susceptible to the confirmation bias. We'll explore this more in class. The final topic covered here in this online lecture is emotion. So take a moment to think, what is an emotion? What does it mean when you feel sadness, or happiness, or anxiety, or fear, or disgust? We have a great intuitive sense of what that emotion is. In fact, even as I just say those words, anxiety, disgust, you could probably even feel that emotion. But what are emotions? One way to think about emotions is by identifying the components that make up an emotion. And the overall emotional experience can be seen as involving an interaction of these three components. The first component being cognition. In this case, specific thoughts about an emotion and an inner awareness of a feeling. For example, part of the emotion of fear might be the thought, I am afraid right now, or this is a scary situation. Additionally, emotions involve physiological sensations. These are changes in physical arousal that are part of the emotional experience. For example, as part of the emotion of fear, one might experience an increased heart rate, changes in respiration as breathing becomes more rapid, and sweating. And then emotions also involve behavioral responses. One of the behaviors that goes along with fear might be escaping a situation in which one is feeling fear, trying to escape or avoid that situation. Part of the emotion of sadness, for example, might involve thoughts about loss, thoughts about being down, a physical sensation of tiredness, and the behavior of crying. These three components make up each of the emotions. Importantly, individuals don't just experience emotions, but we also respond to emotions and regulate our emotions. Emotion regulation refers to the process of modifying one's experience of emotion. Sometimes when we experience sadness, we might engage in behavior that's designed to reduce that sadness. We might talk about our sadness with someone else. We might distract ourselves. Or we might let the emotion play itself out. Interestingly, these 6 emotions appear to be universal across all human cultures. Happiness, surprise, fear, sadness, anger, and disgust. Every single human being across basically every culture appears to experience these 6 core emotions. It's likely that these 6 emotions are also evolutionary adaptations, naturally selected through the process of evolution, because they signal things about our environment and help facilitate our survival. Indeed, these 6 emotions, across almost all cultures across the world, are associated with the same 6 facial expressions, and you see them here. For happiness, surprise, and fear across the top row, sadness, anger, and disgust across the bottom row, as these facial expressions communicate the experience of these emotions to other people. When we express facial expressions associated with sadness, it signals to other people to respond, to attend to us, to help us out. When we experience fear and display the facial expression associated with fear, it signals to someone else, hey, there's danger around here, be careful. So these are 6 universal emotions. We have now discussed the concepts of memory, cognition, and emotion, and that concludes this lecture. I invite you to complete this learning check, reflecting on the most interesting or most important thing you learned, reflecting on what might remain unclear or confusing. And if you have any questions, please email me or bring your questions to class so we can discuss anything that you might want to talk about.